Alright, this video is for Unit 8, Lesson 3. We're going to be talking about trig ratios today and using trig ratios to solve for unknown side lengths in some right triangles. So last time we looked up some triangles on the computer and we found some of their different ratios. Had you looking at the ratio of the adjacent leg divided by hypotenuse, the opposite leg divided by hypotenuse, and the opposite leg divided by the adjacent leg. And you were assigned an angle, so maybe you were assigned the 50-degree angle, and you built some triangles on the computer and you calculated these ratios. And those ratios would be the same in any right triangle with a 50-degree acute angle. So they would apply to this triangle that we have on our screen right now. Has a 50-degree angle down here in this corner. So we're going to use this table of values to help us calculate the length of the hypotenuse, which is marked with a Z in this diagram. So hypotenuse is what we want to find. And we can use the side that we know the length of, which is this side that's along the bottom. GH is length 3. And from the perspective of that 50-degree angle, like if you were standing right there with your little feet looking out at that triangle, this would be the leg that is adjacent to you. So if we know the adjacent leg and we would like to know the hypotenuse, we're going to be using an adjacent leg to hypotenuse ratio. And for a 50-degree angle, that ratio is 0.643. So if I set up an equation, I know that this ratio of the adjacent leg divided by the hypotenuse is going to be 0.643. I put the 3 on top because that's the adjacent leg, and I put the Z on the bottom because that's the hypotenuse. So I know that 3 divided by Z has to be 0.643. So if I want to solve this equation, I need to multiply both sides of the equation by Z, which cancels the Z out on this side. So my equation now looks like Z multiplied by 0.643 is equal to the number 3. And we're trying to solve for Z, so we need to divide. And we'll divide both sides of our equation by 0.643. That will cancel that out. And of course we do it to both sides of our equation. So we can now use our calculator to calculate Z. Z is equal to, and in our calculator we will take that 3 and divide it by 0.643, and we get 4.67. And again, I just used the calculator to calculate that. So the hypotenuse in this triangle is length 4.67. Well, these ratios that we worked with last time, adjacent leg over hypotenuse, opposite leg over hypotenuse, opposite leg over adjacent leg, those are called trigonometric ratios. And each of the trigonometric ratios has a name. We call the adjacent leg divided by hypotenuse ratio the cosine. We call the opposite leg divided by hypotenuse sine. And we call the opposite leg divided by the adjacent leg tangent. So those are their names, and they're called trigonometric ratios. Trigonometry, the trigon part of it means a three-sided shape, which we usually call triangles, and the metron part of it means to measure. So The word trigonometry means basically that we were talking about the measurements in triangles or measuring triangles. So these are ratios, cosine, sine, and tangent, that help us figure out the measurements in triangles. Now, the cosine ratio is dependent on the angle. So you could talk about it for a 20-degree angle and it will have one value. Or for a 60-degree angle, that cosine will have a different value. Cosine of 40 degrees has a value of 7.66. So we usually talk about them with angles. So we would say the cosine of 40 degrees. So this in words is cosine of 40 degrees. And then we would say what it's equal to. So in this case, the cosine of 40 degrees is equal to 0.766. So if I was talking about tangents, I might say that the tangent of 50 degrees is equal to, and on my chart that happens to be 1.192. So we read it with the word of, and it always will have an angle with it. We'll never have just cosine equals. It's got to be cosine of the whichever angle equals. So our table that we created last time was limited to angle multiples of 10. So we looked up 10 and 20 and 30, 40 degrees and so forth. But your calculator knows this table. It has it in its memory, and it also knows the sine, cosine, and tangent for all of the other angles as well. So you could test your calculator out. You could look at it. Please find those buttons that tell you where the sine or that allow you to calculate the sine, cosine, and tangent. And they are located. Let me pull up my calculator. They're located above the numbers in the TI-30. It just has the first three letters of each of those. So it has SIN for sine, it has COS for cosine, and it has TAN for tangent. So the button, for example, if I wanted to calculate the tangent of 50 degrees, I could just type it in like that, tangent 50 for tangent of 50 degrees, and hit enter, and it will calculate it 1.191753. So our table only had 3 decimals. Your calculator knows 9 decimal places for that, and may in its memory be using more, but I'm not sure. Anyway, the nice thing about the calculator is it's not limited to just those angles that we had on our table. Like I said, you could do any angle, including decimal angles. The sine of 58.5 degrees could easily be calculated. There are different modes that a calculator can be in. So you do want to make sure that your calculator is in degree mode, which is right here. If you are getting answers and doing homework and your answers are not correct, one reason could be that the mode of your calculator is not right. So that's something to check. Sometimes it's because you set up the equation wrong, but sometimes it could be if your calculator got into a weird mode. All right, so from now on, we won't have to refer to this table that we created. From now on, we can use our calculators. So here's our super duper official sine, cosine, and tangent definitions. The sine of an acute angle in a right triangle is the ratio of the length of the opposite leg to the length of the hypotenuse. So anytime we are working with a sine, we are working with the opposite side from that angle and from the hypotenuse. When you're setting up an equation, it's always going to look like this. It's going to have your trig ratio. Then it will have That theta is standing in for an angle, so it'll be the sine of the angle, and that will be equal to a fraction where it's the opposite leg divided by the hypotenuse in the case of sine. Cosine works the same way, except the two sides that we're using are the adjacent and hypotenuse. But the angle would be with the cosine here. It's always the cosine of the angle equals the fraction. And then tangent is going to use the opposite side from the angle and the adjacent side. So it'll be the tangent of the angle, the reference angle, is equal to the opposite divided by the adjacent. So it takes a little bit of practice to get these equation setups correct. You have to really think about which of the ratios you're using, whether it's sine, cosine, or tangent. You have to remember to use the angle, and you have to get the fraction right, which one is the numerator and which side is the denominator. So we're going to go through several problems and just practice it. One little mnemonic device that we often use to help us remember which of the sides goes with sine and which goes with cosine and which one goes with tangent is we usually often say SOHCAHTOA. So that is so is sine for S is for sine, and it's opposite over hypotenuse with the fraction part of it. Cosine, we've got CA, so it's the cosine ratio is adjacent over hypotenuse, and the tangent is opposite over adjacent, so we have to say TOA for that one. So that's just a mnemonic device, like a little memory device to help you keep track of which sides go with which ratio. So a minute ago we solved this problem, and we used our table of values, and we did finish it up, and we said that z was 4.67. What we're doing now, we're going to be using our calculator. The process is kind of the same. Our equation setup is going to be just like this, except instead of looking up that ratio in the table, we'll use our calculator for it. We're also now not limited to those 10-degree increments, so our angle for this one is going to be a 56-degree angle. So let's try it out. So the first thing that I would usually do is mark my reference angle like I did in highlighter. Or if you don't have highlighters or don't like to highlight, maybe put a star or something there. That helps you focus on the fact that that's your reference angle for this problem. And then I look and see what I'm trying to figure out. So for this problem, I am trying to figure out the hypotenuse. So I'm trying to calculate the hypotenuse. And I look and see what I know, and the one that I know for sure down here at the bottom, that's the adjacent side. So for this problem, I'm going to use, because I know the adjacent side and I want to know the hypotenuse, I'm going to use a cosine. This problem right now does not involve the opposite side at all, so I can't use a sine or tangent to help me. So I'm going to use the cosine ratio, and I set up my little equation. So it's going to be the cosine of the angle equals a fraction. So in this case of this triangle, it's the cosine of 56 degrees. And the adjacent leg goes in the numerator, and the hypotenuse goes in the denominator. So that's what our equation setup looks like. And now we just need to solve that equation. And this is, one of the more tricky ones to solve. Because that x is in the denominator, we want to times both sides of our equation by x. And the one over there on the right-hand side just cancels out. So now our equation looks like x times by the cosine of 56 equals 3. And our final step is going to be to divide by the cosine of 56, which cancels that value out. So our equation is essentially finished. We just need our calculator to crunch those numbers for us. So we're going to ask our calculator, what is 3 divided by the cosine of 56? And let me see if I can pull my calculator back up. Whoops, eek. Sorry. TI. So you can either use, you've got a couple options here. You can use that fraction bar if you want, 3 over cosine 56, like that. That'll give you the answer. Or you can use division, 3 divided by the cosine of 56. And it will give you the same answer, 5.36. And again, we're just using our calculator on that last step. All right, let's try setting up a couple more. So here's a triangle, 60-degree angle right here on this right-hand side. So that's going to be our reference angle, 60 degrees. So everything we're thinking about is from the perspective of this 60-degree angle right here. So the side that we're trying to calculate, from the perspective of that 60-degree angle, that's the side opposite it. And the one that we know that can help us calculate that opposite side is the adjacent side. So this problem does not involve the hypotenuse at all. So the trig ratio that we need to use, the one that relates opposite and adjacent, is the tangent. So we're going to set up a little tangent equation. So our equation is going to look like the tangent of the angle, so the tangent of 60 degrees, is equal to, and for tangent, opposite is in the numerator and adjacent is in the denominator. So this is going to be x over 4. And in this case, x is in the numerator. So we can solve this equation by multiplying both sides of our equation by 4. So the left side of our equation is now 4 times the tangent of 60. And the other side of our equation, when we multiply by 4, those 4's cancel out. That's why we chose to times by 4, and that's just x. So we can use our calculator to calculate that. It's 4 tangent 60. So we type in 4 tangent 60, and you can put a multiplication symbol between the 4 and the tangent if you want, but you don't have to. And when we crunch that, our calculator says that the length of that side is 4 root 3. So root 3. Now, if you wanted a decimal answer on this one, you could. That would be fine. You'd use this little button right here to get that, that decimal approximation. But it's also fine to just leave it as a radical. Every once in a while, it'll give you a really strange radical. For root 3, though, you might have noticed when we started, or maybe you didn't, but this is one of our special right triangles. It's a 30, 60, 90. So we could have gotten that short leg just by remembering, or the long leg, that if we take that short leg 4 and multiply it by root 3, we get 4 root 3, which is what we got using the trig ratio as well. So special right triangles are just kind of a time saver. If you know them or remember them, you can always use them. If you can't, you've got a couple backup plans. You can now either use a trig ratio or you could use the Pythagorean theorem to help you find the missing side length. in a special right triangle. All right. Here's one where we don't necessarily have a diagram at the beginning, but it gives us the information verbally in words. So we've got the measure of angle C is 90 degrees. Well, this one in my little triangle diagram is the 90-degree angle, so we'll call that C. Angle B is 12 degrees. I'm going to put that over here because it looks kind of like small, and a 12-degree angle is pretty small. If you labeled it differently, it wouldn't matter. You could still get your answer just fine. And then it says side AC has a length of 2 centimeters. Well, this one's got to be A, which puts AC right here, 2 centimeters long. Our question says, what is the length of side AB in this triangle? So we're trying to find this side. So if we think about the perspective of this triangle and how this triangle is set up, here's our reference angle. The side that we know or are given is the opposite side. It's way over on the other side of the triangle from that 12-degree angle. And the one that we're trying to calculate is the hypotenuse. So the ratio that relates adjacent, sorry, not adjacent, we are using opposite and hypotenuse, so we are going to use the sine ratio. That's the one that relates opposite and hypotenuse. Our problem right now does not use the adjacent. So if we set it up, we're using a sine ratio, and it will be the sine of 12 degrees is equal to, and opposite is in the numerator, and hypotenuse, which is what we don't know, what we're trying to find out, is in the denominator. So to solve this equation for x, right now x is in the denominator. We're going to multiply both sides by x so that we no longer have our variable in the denominator. So our equation looks like x multiplied by the sine of 12 degrees is equal to 2. And now we can divide by the sine of 12 degrees. And at first it kind of seems a little weird to be dividing by this strange sine 12 degrees thing, but it works great, and you'll get used to it, even though it does kind of look a little weird at first. So on the left-hand side of our equation, we now just have x equals, and we can use our calculator to calculate this. So our calculator can tell us what 2 divided by the sine of 12 is. 2 over the sine of 12. Whoa, got a little happy with my signs. And it is 9.62 if we round. And that would be the length of the hypotenuse, 9.62. All right, here is another one. It says solve for y. Now, all of our trig ratios apply to right triangles, and I don't see a right angle in this triangle. So let's see if we can figure out what that angle at the top is. We know that the angles have to add to 180 in a triangle. So that top angle, F, is 180 minus 42 minus 48. And when we do that subtraction, we find out that angle F is, in fact, a 90-degree angle. So we do have a right angle in this triangle, and we can use right triangle trigonometry to help us solve this. So at this point, you could choose which of the angles you want to use as your reference angle. I'm going to use this 48-degree one just because I feel like it. You could absolutely do this problem using the 42-degree angle as well. The setup would be a little different. from the perspective of that 48-degree reference angle, the side that we're trying to calculate, y, we would call that the opposite leg. And the side that we know down here that says 7, that's the hypotenuse of this triangle. It's across from the right angle, and it's the longest side of the triangle. So opposite and hypotenuse are related as a sine ratio. So we're going to use sine again. So the sine of 48 degrees is equal to, we want the opposite in the numerator, and we want to divide that by the hypotenuse. So y divided by 7. So we're trying to solve for y. So we'll multiply both sides of the equation by 7. That one cancels out, and we get 7 sine 48 equals y, at which point we could go ahead and use our calculator. And we want to do 7 multiplied by the sine of 48. And our calculator tells us that that is 5.20. Another one. And really the trick here is to get used to identifying opposite, adjacent, and hypotenuse so that you can choose the proper ratio to use, either sine, cosine, or tangent. So in this triangle, it says that the angle K is 90. So I'll label the K down here. Angle L is 71. I'm going to put that over here on the right side. And then side LM has a length of 20. We must have an M here. LM has a length of 20. Our goal is to find the side that is marked KM. So this one. Now from the perspective of the angle that we are given, 71 degrees, we would call this the opposite side. I'm going to call it X. And the side that we know would be over here. This is the hypotenuse of that triangle. So we need to use the ratio that relates opposite and hypotenuse. So opposite and hypotenuse, we're going to use the sine. So if we're setting up our equation, the sine of the angle, so the sine of 71 degrees, is equal to the opposite over the hypotenuse. So the opposite side I marked as an x, that's the side we're trying to calculate, and the hypotenuse is 20, so x over 20. So solving for x, we just need to multiply both sides of our equation by 20. When we do that, this 20 cancels out, and we can use our calculator to crunch this. So 20 sine 71. And we get 18.91 as our side length. Make sure when you're doing these problems that you always take the time to write out your trig ratio. When students kind of decide that they don't need to do that, they often make errors and they often don't end up with the right answer. So please make sure you're taking this time to write out your equations. All right, this one, we want to calculate the length of the hypotenuse. So our reference angle is right here. The hypotenuse is our unknown that we're trying to figure out. And this side that's marked length 10 from A to B in this triangle, that is the adjacent side. So the trig ratio that relates adjacent and hypotenuse is cosine. So we're going to set up a cosine function. So we've got cosine as our ratio. Cosine of the angle, cosine of 17 degrees equals the adjacent is in the numerator and the hypotenuse is in the denominator. So we're solving for a denominator x this time. So we can solve for x by multiplying both sides of our equation by x. That cancels this one out. It's when x is in the denominator, that's what you want to do. So our equation now looks like x multiplied by the cosine of 17 degrees is equal to 10. So we want to solve for x by dividing by the cosine of 17 degrees. Cancels out over here, and we're ready to input into our calculator. So 10 divided by the cosine of 17 degrees. And we get 10.46 if we round it. All right, last one. This one has instructions that say solve triangle KLM. So when it says to solve a triangle, it's telling you to calculate all of the unknown side lengths and all of the unknown angles. So we really have one angle that we need to figure out, and we have two side lengths that we need to figure out. So the angle L, isn't too difficult to calculate because we know that we have a triangle, so we know that those angles have to add up to 180. So if we subtract the two angles that we know, it should give us the measure of that third angle L. So 180 minus 90 minus 24 gives us 66 degrees. So angle L is 66 degrees. So one down, we got two more things to figure out. We need to find the length of side, the LK, and the length of side LM. Let's find this one first, KL. In our triangle, we're going to use this reference angle 24 degrees right here. And the side that we're trying to figure out right now is the side that is opposite. It's the opposite leg. And we know the adjacent leg. So we get to use a tangent, because tangent is the ratio that relates opposite and adjacent. So the tangent of 24 degrees, so tangent is going to have that angle in it, equals, our ratio is going to be opposite over adjacent. So for opposite, I'm just going to write LK, and adjacent has a length of 8. So if we're trying to solve for the length of LK, we can just times both sides of that equation by 8. The one on the left cancels out, and we can use our calculator. 8 times the tangent of 24. And our calculator tells us that that's 3.56. 3.56. All right, and then we have one more side to find. That is the side that is marked from M to L. Now, in that case, we are going to be calculating the hypotenuse. So if we are thinking of how to set up our triangle, we're going to be using that adjacent side again, and we're going to be using the adjacent side to calculate the hypotenuse. Well, adjacent and hypotenuse are related by cosine. So our equation looks like the cosine of 24 degrees is equal to the adjacent in the numerator and the hypotenuse in the denominator, and I'll just call that LM. You could put an X or a Y if you liked it better. So we're trying to find the length of LM, so I'm going to multiply both sides by LM. So now I have LM multiplied by the cosine of 24 degrees is equal to 8. And to finish solving that, I'm going to divide by cosine 24. And we can use our calculator to calculate that. We need to type in our calculator 8 divided by cosine 24. And we find that it is 8.76. And so we were able to solve that triangle because now we know exactly how long all of its sides are, and we know the measure of all of its angles. So the assignment has some special right triangles to review, but it also has on the back several of these to set up and try to calculate. Don't forget to check your work and make sure that you're setting up your trig ratios right. If you're getting them wrong, it probably means that you're not identifying the adjacent side right, or you're mixing up the opposite or the hypotenuse or something. So if you're finding that you're not getting them right, please come in and get some help setting them up, because you'll definitely get the hang of it after a while. Sometimes it's helpful to write this little mnemonic on the top of your paper so that as you go through, if you notice that you're trying to calculate an adjacent and you have a hypotenuse, it can kind of just help remind you that you're using a cosine or whichever one. So it's just a good little memory device that helps you set up your equations. Remember to make sure your equations are set up on your homework assignment so that you can get full points. So we'll continue to work with solving with trig ratios in our next lesson as well. And pretty soon you'll be an expert at it. Thank you.